Welcome to this second video on assist control ventilation. It's in this playlist of principles of mechanical ventilation. In this video we're going to look at assist control, volume control ventilation. So in the last video we went over a little bit of the sort of details and intricacies of assist control, just trying to get our heads around what that means and how the ventilator and the patient interact. So what assist control of this phrase here, what the assist control part tells you, let me just get a pen going here, is it tells us how does the patient and the vent interact. Okay, that's really all the assist control part tells us, is what is the relationship between the ventilator and the patient here? Is the ventilator doing all the work? Is the patient doing all the work? Is there a mix in the work being done by the ventilator and the patient? And sort of what happens as the patient interacts with the ventilator? So that's what this assist control part really says. And then the volume control part tells us, okay, so when those breaths are being delivered by the patient or being instigated by delivered by the ventilator or being instigated by the patient, how are those breaths being delivered? So volume control part says, how are breaths delivered? How are breaths delivered? Okay, so that's really, you need to view these as two parts, and I stressed this a little bit in the first video, but let's say we change this to assist control, pressure control. The assist control part is still the same. All that tells us is what happens between the ventilator and the patient. How do they interact? And then the volume control part is, okay, well, how are the breaths delivered? What are the sort of rules or the sort of algorithms around how each breath is delivered? And that's what the volume control part says. So to make this video a little easier, what I thought I'd do is bring up a sort of screen picture of a modern ICU mechanical ventilator. So that's what we're going to do here. The picture's not the greatest quality, but you should still be able to see everything going on here. And we're going to take a look at this and try and sort of just familiarize ourselves in this video with a ventilator screen. You may not have seen one of these before, and this might look like a lot of information, a lot of sort of foreign terms, and we're going to kind of slowly piece our way through these. And we're going to sort of look at volume control and what the type of things do we set, and what type of things does the ventilator measure during volume control ventilation. So let's take a quick look at this screen here. So we can see here that we have, down in this bottom section, we have these blue boxes. And what these are the values that we as a clinician input into the ventilator. So if you're the respiratory therapist and you're entering in the values into this ventilator, these are the ones that we're picking. So this is a respiratory rate. It's often termed F for frequency. So 21 over a minute, so 20 per minute. So that's 20 breaths per minute. This is a tidal volume, right? So this is the volume that they're going to get each breath. Remember, we're in volume control ventilation, so this is how much tidal volume they're going to get each breath, and they're going to get that 20 times a minute. We've set this into the ventilator. Okay, this is a flow, which we'll get to in a second. It's an inspiratory flow. We're going to talk a lot about that later on. This box here is a flow waveform. It says, okay, well, how do we want the flow to be delivered? We're going to talk about that as well in a bit. This one here is a plateau time. We'll get to that much later on. It's less important for understanding the core concepts of volume control ventilation, but we'll get to it in a bit. And then over here we have, this is our oxygen concentration. We can see here that 21% oxygen is what we're giving to the patient. So that's obviously just room air, regular air. This is PEEP, positive end expiratory pressure. We'll talk about what that is. And then this is a trigger. So remember how we talked about if a patient wants a breath, they have to trigger the breath. Something needs to trigger the ventilator to give them a breath. And before we just said, oh, it's patient triggered, or it's machine triggered, or it's like ventilator triggered. So this is what's called a trigger variable. This is how does the patient trigger a breath, okay? And this is a flow. So it turns out that if the patient generates a change in flow of the circuit of 3 liters a minute, that tells the ventilator that the patient wants another breath, so it gives him one. Okay, so what do we got? We've got respiratory rate, volume, flow and oxygenation stuff, okay? And we can see here that this is our AC, assist control, and volume control. So our two types of breaths are assisted breaths, right? And controlled breaths. So if you don't know the difference between those two, go back to that first video on assist control ventilation, and there's an explanation there. Basically, one is triggered by time, just every, in this case, it's 20 breaths per minute. So every 3 seconds, the ventilator is going to deliver a breath, and it's going to be 500 mils, and it's 60 liters a minute of flow. Okay, so these are controlled breaths because they are triggered by time. The patient doesn't have to do anything. These are just going to come in anyway. An assisted breath is where, in between one of these control breaths, the patient decides they want an extra breath. So extra on top of the control ones we've already given. So they have to trigger that. Okay, so it's going to be the same as the control breaths, 500 mils, 60 liters per minute of flow, but it's going to be triggered by the patient. Okay, so there's assisted breaths and control breaths. That's assist control ventilation, right? So we can see now that in volume control ventilation, we are targeting a volume. Okay, we're targeting tidal volume, we're controlling with flow, and we're setting our respiratory rate. Now up the top here, we have some measured values. So these are things which the ventilator is going to measure. These aren't things that we input. Okay, so if you input volume into the chest, as we deliver volume into a patient, that causes the pressure in the chest to increase, right? That's Boyle's law. P1V1 equals P2V2. That's Boyle's law. As you input volume into a closed system, the pressure inside that system is going to increase. So we want to keep an eye on what the pressure is inside with our patient, right? Because as we input volume, our pressure is going to change. This is going to vary based on how stiff the patient's lungs are. If the patient's lungs are really stiff and we want to put all of that 500 mils in, it might require quite a lot of pressure. It might make the pressures quite high. And similarly, if the patient's lungs are quite floppy, or we call that very compliant, then maybe this pressure will be very low to get this in. So we want to look at what the pressure is, okay? And this peak, that's the peak pressure. That's the highest pressure during the breath cycle, okay? And you can see it just up here. This is a pressure waveform, which I'll tell you about in a second. You can see that's our peak pressure right there. Peak pressure, like that. Okay, mean pressure is what is the pressure over the whole breath, like averaged over the whole breath. So that's our mean pressure. This is our PEEP, our measured PEEP on the ventilator. Obviously we set a PEEP here, and ideally this should be the same as this. And this ventilator here, I hooked this up to a test lung when I was at work the other night. So it's not perfect in terms of measuring how it is, but this is the measured PEEP. This is our inspiratory to expiratory ratio. So 1 part inspiration for every 5 parts expiration, right? And then this is our total frequency. And right now, this is the same as our input frequency because this is hooked up to a test lung, and the test lung isn't initiating any breaths. It's not triggering any breaths, obviously, because it's inanimate. So the total respiratory rate here that's measured by the ventilator is the same as our set rate. If the patient was to start triggering extra breaths on top of the 20 that we're giving him, this number would go up. So this number might be 24 and this might be 20. So then you could see that the patient's taken 4 extra breaths. This is expired tidal volume. When the ventilator measures volume, it measures it on the expiratory end. So there's 2 limbs of a ventilator circuit. I'm not sure, I'll just draw this. So there's limb 1, then it comes to a Y piece. Okay, so there's our first limb, and then there's a second limb of a ventilator circuit. Okay, coming in and out of the ventilator. So this is in, this is the patient, and then it comes out. Okay, so back at the ventilator over here, the ventilator measures in this area, it measures the volume coming back into the ventilator. So this is why this is tidal volume, V subscript T with little e. It's expired. Okay, so this is our inspiratory, blow it into the patient, and then the patient exhales it back out. Okay, so we have, it's measured on the expiratory side. And then this is our minute ventilation. So 500 breaths a minute over the whole minute. So if you think of 500 mils times 20, should be about 10 liters, right? And that's what it is, so 10.1 liters per minute of minute ventilation. Okay, so these are our measured values. These are our input values that we select. And then these are our waveforms. Okay, So what I'm going to do, I'm just going to undo this little chicken scratch, and I will, earlier on I brought up these, so you can see here, just to save you watching me painfully write out all these words for a very long period of time. So you can see here we have our input parameters, respiratory rate for our control breaths, right? These are going to be control breaths. Tidal volume, inspiratory flow is number 3, plateau time, flow waveform, the trigger for assisted breaths, our FiO2, fraction of inspired oxygen, and our PEEP. So we set all of those. We choose what we want those to be, and then the ventilation happens, and then the ventilator measures a bunch of values. Peak pressure, mean pressure, it measures the PEEP, measures our IE ratio, measures our total respiratory rate, our tidal volume, and our minute ventilation. Okay? And then these are our waveforms. This one here is a pressure waveform. It measures the pressure in the circuit through the breath cycle. And this is a flow waveform. It measures the flow through the breath cycle. So you can see how this is a breath starting right here. Inspiration is this green part. The flow goes up, right? And then it holds that flow for a certain period of time. And then there's negative flow as the patient exhales that back through the circuit, and then it comes back to 0. Okay, and then there's positive flow, and you can notice how this flow here, let me come back to this line. Our flow here, oh, I just completely covered that up. It says 60, right? You can see that's 60 liters a minute, and that's our peak flow. And look, that's what we set for our flow, right? So you can see that it's at 60 liters a minute, and this waveform kind of looks like a square, right? Which is kind of what we've set here. So we've set how we want the flow to be delivered. So the flow goes to 60 liters a minute, and then the breath ends, which I'll talk about in a sec. And then there's negative flow as the patient exhales, and then it happens again, and then it happens again. Okay, so you can see that this is a flow waveform, and then this is a pressure waveform. Okay, so this is just really just to familiarize you with the screen and what things look like. And then maybe in this next video that I'll do after this one, we'll start to dig a little deeper into the intricacies of this and how we calculate things and why we set flows at different levels. Okay, so hopefully this gives you an idea of what a ventilator screen looks like, and what's the difference between the values that we set and we input and the values that we measure, and then some waveforms that we can look at while the ventilation's happening. Okay, so I'll see you in the next video.